Hi everyone, welcome to Netgate Chemistry. So far we have covered two types of graphs, right? That are your straight line and your exponential graphs. So in this video we are going to cover the parabolic and hyperbolic graphs. Okay, so these type of graphs are going to be very helpful for you before starting out with your chemical kinetics, right? So first we'll start with the parabolic graphs. For parabolic graphs, we can get two types of equation. Y is equals to plus minus root x and x is equals to plus minus root y. From here, suppose first I am taking this equation. If I square both sides, on squaring both sides, what I can get two types of equation from this single equation, that is y square is equals to x and y square is equals to minus x, right? And if I do squaring both sides in this equation, then from here also I can get two types of equation, x square is equals to y and x square is equals to minus y. So these are basically your four equations for parabolic graphs. If you get equations like these four in any of your questions, then you have to understand that the graph will be parabolic. But all of these four graphs will show the shapes in different quadrants. Now what are your quadrants? See, when you have your x and y axis like this, suppose this is your positive x-axis, negative x-axis, positive y-axis, negative y-axis. Then this quadrant, this is your first quadrant, this is your second quadrant, this is third quadrant, and this one is your fourth quadrant. Okay, these are the four quadrants. So based on the type of the equation out of these four, the graph changes its quadrant. So we'll discuss all these four cases of parabolic graphs. So first is the case of y square is equals to x. The graph is like this. Okay, this type of curve is called parabolic curve, and the parabolic curve occupies first and fourth quadrant. Okay, now for the second type of curve, which is y square is equals to minus x, the quadrant is opposite of this. Like this. Here the parabolic curve occupies your second and third quadrant. This is second one. Now for third, x square is equals to y. The curve is like this. See, the x's are the same. This is positive x-axis, negative x-axis, y and minus y. X-axis, minus x-axis, y, minus y, x, minus x, y, minus y. Okay, and the fourth type of graph is x square is equals to minus y, which is like this. And okay, here the quadrants are first and second. Here the quadrants are third and fourth. Okay, so these are the four types of parabolic graphs. Okay, so depending upon the equation you will get the graph. So now we'll move on to the hyperbolic graphs. Okay, the equation for hyperbolic graph is x to the power m y to the power m is equals to constant. So basically the powers of x and y should be same, where m is also a constant, okay, but not this one, okay, or it could be any constant, okay. So this is the equation for hyperbolic graph. So how this hyperbolic graph looks: here I have my positive x-axis, negative x-axis, positive y and negative y. The graph is like this. Okay, this is the hyperbolic graph. Now if suppose there are so many 2 to 3 types of equations given to you, and you have to find out which one equation is preferred for which one type of graph. For example, you have been given 3 types of graphs like this. Okay, first you have been given equation xy is equals to constant. Okay, this is the first equation. Second equation is x square y is equals to constant. Okay, you can call it m dash. It is different, right? Your m dash and m could be any constants. They could be different also. Third is x cube y is equals to constant. Now what will be the difference between the graphs of these 3 equations? Here we can notice that only the power of x is increasing, right? So based on the increase in the power of these 3 equations, what is the difference we are going to observe in the graphs? So suppose for xy is equals to constant, we have plotted a graph like this. Right, so for x square y, the graph will be more steep. The slope of this line will be more steep. Okay, and for third one it will be much more steep. From steep I mean, suppose you have a football here. Okay, now if you allow it for free fall, right, so what happens, the slope is not much steep, so here the velocity of this ball will be less as compared to these 2 cases. Here the slope is much more steep, right? So what happens here, the ball will go with more speed as compared to this one, and here the speed of ball will be most because the slope is much steep here. Okay, so here what is happening, there is change in the slope, right? Here the slope is most steep. Okay, most steep slope. So as the value of this power increases, the slope becomes steeper, right? This is what we observe when we see a graph for hyperbolic curves. So this is the main point which we have to remember, that is whenever there is increase in the power, what happens, the slope is becoming steeper, right? So this is all about your hyperbolic graphs. So with this your graph section is over. So far we have covered 4 types of graph: straight line graph, exponential, parabolic and hyperbolic graphs. So after this you can start with your chemical kinetics. And for electrochemistry, if you are doing your electrochemistry, before that you can see the part 1 and part 2 of general concepts of physical chemistry. That is going to really help you, especially if you have non-mathematical background. If you belong from biology background, it is going to really help you guys. Okay, so after this I'm planning to start another topic, which is your electrochemistry, right? After that we'll also do polymer and surface, and then we'll plan ahead for the other topics. So far that's it for this video. Thank you so much for watching.